So hi guys, I am again Andre Alferos from ECE22 and here we are to experiment Python again for experiment number 4 about operators and expressions. So the objectives of this experiment are becoming familiar with the concept of numbers, operators, and arithmetic operations in Python, becoming familiar with the concept of comments in Python, using and not using comments and replacing comments with code, becoming familiar with the inputting and outputting of data in Python, and lastly evaluating simple expressions. So just like before, what we always do is open the IDLE and there you go. So for the part 1, scenario 1, take a look at the code in the editor. It reads a float value, puts it into a variable named x, and prints the value of a variable named y. Your task is to complete the code in order to evaluate the following expression. So this expression, 3x to the fourth minus 2x cubed plus quantity 3x minus 1 quantity squared. So as we can notice, we cannot put this in the Python ideally like 3x to the fourth. We cannot express this as exactly as this, but we can express this using the symbols of Python. So I have made the data and it says what are the sample inputs are x equals 0, x equals 1, and x equals negative 1. So as I have tried this, what are the expected outputs? The expected outputs are when we plug in x equals 0 in the equation, y must be equal to 1, x equals 1, y must be equal to 5, and x minus 1, y is equal to 21. So let's try it. So upon discovering the Python operation or equation for this, I have ended up with this kind of mixtures of asterisks, additions, subtractions, and parentheses. So let's try it. Let's run our code. So if x is equal to 0, then we plug in the equation and lastly let us print y, and it says it should be equal to 1. Let's see. Yes, it is equal to 1. So let's try the others. Lastly, print y should be equal to 5, it says. There you go, equal to 5. And lastly, when x is equivalent to negative 1, there you go, y rather is equal to 21. So we have found out that this equation can be written with this equation in Python. So proceeding with the part 2, scenario 2. So let's read this. The code in the editor contains comments. Try to improve it, add or remove comments. So what we are going to do now for the part 2 is something like proofreading this. So let's read this. The first line says it started with a hash, so it is a comment. This program computes the number of seconds in a given number of hours. So my observations are in the line 1. It shows the goal of the program, which is to compute the number of seconds in a given number of hours. Yes. For the second one, hash. This program has been written in written 2 days ago. So for me, I think this can be removed. Yes, absolutely, since we do not need to know anymore when the program was made. Like, what is the connection of it, right? Does it matter? So let's put it 3 is blank 4. So it says a is equal to 20 hash number of hours. But for me, based on my observation, replacing a into age would be much easier and practical because we are dealing with the unit hours. And that hours started with letter age, so it would be practical if we use the same starting letter. Number 5, fifth line, seconds equals 3,600 hash number of seconds in 1 hour. Yes, we have 3,600 seconds in 1 hour. But again, for me to make it identical, seconds can be just expressed as s. So that is shortening or having the abbreviation of seconds, but we can simply lessen the use of letters. We can omit those letter s or seconds by making it like age asterisk 3600 or age times 3600, in which the goal is also to get the number of seconds in an hour and not only in 1 hour. Okay, so something like applicable for all. Number 6 is blank. Number 7, print hours colon a hash printing the number of hours. So my observation must be replaced with the print hours age, not a anymore, since we have replaced it. Then that's it. For the number 8, hash print seconds in hours, a seconds. So printing the number of seconds in a given number of hours in line 8, the code would not work. Yes, because it started with hash. Remember, when we print, we started with small p, then the word print, then the parenthesis, then the quotation inside. So line 8, it should be there are, so the expression seconds in hours, a, then seconds, we can just simply correct our grammar by making it there are, for example, there are 3,600 seconds in 1 hour or 1 hours. It doesn't matter. So we can put this again like 1 hour or hours or seconds there. And the line number 10, hash, here we should also print goodbye, but a programmer didn't have time to write any code. So for me, why would the programmer still say the word goodbye? We can just remove this line or simplify it if we still wanted this function as print goodbye. And lastly, this is the end of the program that computes the number of seconds in 3R. Why? I'm a bit confused why 3R. Something like or particular or specific. Why don't we make it general as must that be only limited in certain 3R limits, since this program was a conversion, so it must work at any number of seconds in each hour. So that's why it should be for all, because we are not only dealing with 3. How about if we wanted 5, 4, right? 1 or 1/2, so it would be applicable for all. And lastly, for the part 3, scenario 3, your task is to complete the code in order to evaluate the results of 4 basic arithmetic operations. The results have to be printed to the console. So okay, that's additional, so let's proceed immediately. So here another codes on the sandbox, and it says hash input a float value for variable a here, and for the second one, hash all our comments, and this one our print function, input a float value for variable b here. So based from what I see, The first two lines indicate the input function where a and b variables are to be placed. Yes, it is the main, the starting part. And through this, output the result of addition here, subtraction here, multiplication here, and division here. That is 4 to 7 respectively. So with the use of the four mathematical symbols, lines 4 to 7 are the spot for print function calculations. It's something like our solution or the one who will compute. And lastly, print, then the function \n, it means it would go one line lower. That's all, folks. So, and lastly, the line is something like a phrase saying everything was done, which can be optionally displayed. So, just like on the previous one. So, I have made a code here wherein from line 1, line 2, 3. So, by the way, this is line 1, but this is also line 2. So, we have an additional 2. So, instead of 9, that's up to line 11 on our console. So let's try this. So I have already inputted everything here, so let's go in the console. There. So a equals input any number, so we can choose from any number. So that is the value of a. And for number 3, b input any number, so any number again, any real number. So float a. Oh, by the way, the second and the fourth one indicates that the value for a and the value for b would be automatically translated or revised into a float value, since we are looking for an input of a float value. So 6 is for the addition, 7 subtraction, 8 multiplication, 9 division, and let's see. So by the way, let's try to give some number. So try 2 and 8. So we have 4 results, and lastly that's all, folks, which is the ending. So let us analyze. So b plus a. So I have written here b plus a, which is equal to 10.0. So we go so close. So plus simply 8 minus a. Print b minus a. So 8 minus 2 is 6.0. 8 times a, or 8 times 2 is 16.0. And 8 divided by a, or 8 divided by 2 is 4. That is the print function b plus a. By the way, I have written here a plus b or b plus a. It doesn't matter, because whatever the programmer wanted to look for it, you can choose optionally. So let us try the a plus b now, because we have used the b first then a. So let us reverse now. Let's see what happened if it would take effect. So the same number, let's try 2 then 8. Oh, results are there. So still a is already 2. 2 plus 8 is equal to 10, float value. So here 2 minus 8 is equivalent to negative 6. It did a correct calculation. So 2 times 8, 16. So that's good. And lastly, 2 divided by 8 is 0.25. So we've proven here that either of the two, a or b, which one comes first will take effect. So we're done with this observation on the part 3. So for our conclusions and recommendations, so here we go. If shortening a certain code was possible, always do it for the sake of less hassle coding, but still the whole thought would not negatively affect the programmer's work, because sometimes a very very long, like a maze type of coding would make your mind burst or confused, jumbled. So it's always good to be on a less hassle situation. So in simple terms, simplicity is also beauty in programming codes. Yes, I do believe here, because if we are to express too much, maybe the one who is going to use, or for other people, they may not understand what it's all about. Always check if you have used the appropriate symbols, especially basic mathematical signs, because the knowledge of computers would not be the same with humans, as they are considered as robots. Although we have inputted some of the correct equation, especially in the first scenario, but still there are human knowledge wherein, for example, the PEMDAS, the computer sometimes would not understand a layman's term, because computers are computers and they are considered as robots. And lastly, just always explore whenever something is lacking or missing, because there are many ways in order to code. Yes, because that's why there are lots of methods or strategies for this coding. And that's all for this experiment number 4. I hope you like it, and thank you.